Well. Hope you guys are doing well. Having a good day. Check us out. We're going to do next lesson, number 7. Dang, bro. More square roots. It's our last one with square roots. We're going to be doing more addition, subtraction, multiplication. I'm also going to show you some division. And we're also going to throw in some unknowns, some variables, some like x squareds, a cubes, all those kinds of fancy things, right? Uh, let's get to it, shall we? So, first of all, what we learned last time is that when you're adding, you had something like this, right? A square root of b plus 3 squared of b. Um, man, I don't know what b is. It doesn't really matter, though. But what does matter is if these are the same, you can add. You can add those coefficients. But if these are different, you cannot. You see? If it's multiplying, it doesn't matter. It doesn't matter at all. So the radicands have to be the same in order to add or subtract. And if you're multiplying, it doesn't really matter. And you're going to multiply everything together. The other thing we learned is that something like this is simplified, whereas something like this is not. Factors of 14 are 2 and 7. The factors of 8 are 4 and 2. That's a square number. These aren't square, they're both prime. So this one is irrational. This one can be simplified. It stays irrational, but can be simplified. So it's simplified if the radicand does not any longer have a factor that's a square number. Square numbers, once again, numbers times themselves, right? For 4 is the first one that really matters. 4, 9, 16, 25, 36, 49, 64, 81, 100, 120, 160. You got it right. All right. So, uh, yeah, that's what we learned. Now let's apply that to let's apply that to some situations with some variables. So let's say we had something like, oh man, let's say we had something like 2x times the square root of, well, let's use 8 again. And then let's say we were going to add that to, let's say 3 times the square root of 2x squared. Oh man. Now, once again, I keep saying it every time, learning is not a passive activity, but watching videos is. You don't really learn from watching a video. You feel good. It seems like it makes sense, but you're being entirely passive. If you want to be I want you to be a good student. That's why I put these together. I put these together to help you to learn. So your job is you got to be a good student when you're watching these. Pause videos, write notes, write questions. Everything I'm writing down, you should write down. You should also write down anything I say that seems like it's important or it's a new idea to you. And then, of course, most important, you got to write down questions. When you're confused, you need to write down a very specific question. And when you come up with the answer, you go back and answer it. Anyway, I'll shut up about that. Let's get into this, right? Now, the way they stand right now, you can't add these because these radicands are different. 8 and 2x squared, not the same. But we need to simplify. So this one can be simplified because the square root of 8 is, of course, 2 root 2. We've seen that one a bunch of times. The reason it's 2 root 2 is because 4 times 2 is 8. So the square root of 4 times the square root of 2 is the square root of 8. That says what times itself is 4, and it's 2. You see? Now, if you're having a little trouble with that, maybe you need to go back 1 or 2 videos, 1 or 2 lessons, go to lesson, 5 or 6. Go back to that. You'll get it under your belt. You'll get it. Okay. Now, here's the deal. We just found out that the square root of 8 is equal to this. So watch. That's 2x times 2 root 2. They're all multiplying. So this is 4x root 2. Do you see? Now, I did 2 steps at once with that without doing anything over here, and sometimes it can get you in trouble. So you got to be neat. Leave lots of space. You see how I wrote a plus there, and I'm leaving the space where I can go ahead and continue this right here. You see what I did? Now, let's look at 2x squared. In order to simplify this, square root of 2x squared, we've got to factor it and look for a square number. Well, that's a square right there, obviously, right? So what squared is x squared? What times itself is x squared? Well, that's just x. So this and this are the same. That's the simplified version of that. If you had something like x to the 4th, that's what it would be. Do you see? Because x squared times itself is x to the 4th. So anyway, this would be 3x times the square root of 2. Do you see? So all I did, you see how those are the same right here and right here? I just simplified them. 3x. So this is 3x root 2. So I did nothing changed from there, but this one just so it's all together. Now, 3x and 4x is 7x root 2. The radicands don't change when you add. Good? See how that goes, right? It's not too bad, I don't think. Now, the square roots can be kind of tricky, the square roots of the variables, but man, We're going to get into exponents next, but if you remember just this much for right now, you're okay. So you'll be all right. Now let's talk about one last thing, and that's what we have to do with division. We have to do this thing called rationalize the denominator sometimes. Now, let's say we had something like this. Let's say we had something like 2 root 8 divided by the square root of 2. Okay, let's talk about this. This one, we actually won't have to rationalize the denominator because, do you remember how if you had, say, the square root of 4 times the square root of 2, that would be the same as the square root of 8? And it goes either way, right? You can start with something that's broken apart and multiply those radicands together, or you can take something that's all together and you can factor it and break it apart. Depends on the situation, right? So like if you had 2 root 5 times 3 root 7, just to review, that'd be 6 root 35. 5 times 7. Now, that's simplified because 35 does not have a factor that's a square number, so it's done. So either way, it goes like that. Now, multiplication and division, they're almost the same. Division is multiplication by the reciprocal. So the same property works. So here's like how they write it in a textbook. They say that these are the same. And it's true, they are. But it works either way. You can start with something that's broken apart, you can put together, take something that's together, break it apart. Here, you see how these are broken apart? Well, I would actually not write it this way, but this is what we do. You see, this is really 2 over 1, right? 2's in the numerator. 8 divided by 2 is 4. So this would be 2 times the square root of 4, and the square root of 4 is 2, so the whole thing is just equal to 4. This equals 4. Boom, done. You see? So let's see another example. Let's say we had 3 square root of 15 divided by the square root of 5. Now, here's the deal. 5 goes into 15 3 times, so the square root of 5 goes into the square root of 15, the square root of 3 times. So this is 3 root 3. You see? So here's one thing that's a big deal about fractions. The denominator has to be a rational number. The denominator of a fraction is a rational number. So this is okay, because here the denominator is 1. This is okay, because the denominator is a rational number, but this is a problem. Because now, look at this. That denominator is no longer a rational number. So we have to do this thing called rationalize the denominator. You don't always have to do it when you divide. And I'm just going to introduce it to you right now. It's something that's going to come up in more detail in the future. But, well, you ever seen remember the show Blue's Clues? Man, when that was a new show, they would show the same episode back to back, twice in a row. Reason why? Kids learn something, well, not just kids, people learn better the second time. So I'm just kind of introducing the idea here, and we're going to come back to it. However, you've got to be able to do these kind today. Same with this, and all of these things up here. You've got to be able to do all those today. We're going to practice some of the rationalizing the denominator, but it's going to be really, really simple cases for now, and we'll get into more of that in depth later. So check this out. 3 divided by the square root of 2. That square root of 2 is an irrational number. Fractions, by definition, have to have a denominator that is rational. That means the whole number, basically, right? Any number that can be written as a fraction is rational. This is irrational. So what we're going to do to fix this is, well, first of all, let's introduce a few ideas. If you divide a number by itself, isn't that equal to 1? Would you guys agree? So the same is true with this, because the square root of 2 is just a number. So that's equal to 1. A number divided by itself is 1. Would you agree? Also, if you multiply a number by 1, it doesn't change its value. It stays exactly the same, right? But what if that number didn't look like 1? Isn't 4 over 4 1? These are all the same. Do you see? So we're gonna kind of apply that here. So this is a problem because the denominator's irrational. So what we're going to do is we're actually going to multiply top and bottom by the same value, because this is equal to 1. When you multiply something by 1, it doesn't change the value. So that's 3 times the square root of 2. 3 is rational, square root of 2 is not. Now look at this. Square root of 2 times the square root of 2, that's just plain old 2. And we're done. Can't reduce it. Those don't reduce. This is 2, as in 1, 2. This is a number times itself that's 2. This is a square whose area is 2. That's what that's talking about. And so that would be the side length. this length right here is the square root of 2. Just like if you had a square whose area was 25, then the side would be 5. So once again, if you had, let's say you had an area whose, let's say you had an area that was 7, well then the sides would be the square root of 7. Do you see? Like that. So anyway, one more example. Let's say we had 5 root. Ooh, let's say we had 5. Now let's keep it simple. Like I said, let's say it's 5 divided by the square root of 6, right? Well, here's the deal. That's irrational. It can't be simplified. 6 isn't prime, it's composite, but it does not have a factor other than 1 that's a perfect square. So, to fix it, multiply just like that. So this is 5 root 6 over 6. Those cannot be reduced because this is 6, like 1, 2, 3, 4, 5, 6, and this is number times itself is equal 6. They're not the same at all. They don't even have a common factor. Can't reduce it. Boom, done. Man, I know it's a quick lesson. Hope it's been helpful. Man, you guys are killing it, bro. Killing it. Anyway, hope you guys have a good day. I'll talk to you later.